Hello and welcome. Today, we're going to pull back the curtain on one of the most fundamental building blocks in all of Java, the array. Whether you've been coding for years or you're just getting your feet wet, really getting a handle on arrays is absolutely key. So let's dive right in.
Okay, let's start with a little thought experiment. Picture this. You've just built the next big hit game for your phone. It's a smash. Players are racking up points, and now you need a way to track the top 100 high scores. You have to store them, you got to sort them, and you need to put them up on a leaderboard. How would you actually do that? You're not going to create 100 different variables, right? Oh my gosh, that would be a total nightmare to manage. This exact problem is why arrays were invented.
And yeah, you guessed it. The answer to our high score problem is the Java array. So for our first section, let's really dig into what makes this simple little container so incredibly powerful. So what exactly is an array? Well, at its heart, it's just a data structure that holds a specific number of items. And, this is important, they all have to be the same type, all lined up in a neat little row. I really love the analogy on the slide. Think of it like a bookshelf. You decide how many slots it has when you first get it, each slot is numbered, and you can only put books in it. You can't just start mixing in DVDs and coffee mugs. It's for books only. This right here breaks down the core personality of an array. First up, it has a fixed size. Our high score list is for the top 100, not 101, not 99. Once you create it, that size is locked in. Second, it's homogeneous. All our scores are going to be numbers, like integers, not a random mix of numbers and player names. Third, and this is so crucial, it uses indexed access. The very first score is at position or index 0. The second is at index 1, and so on. This ability to jump directly to any slot is what makes arrays so incredibly efficient for grabbing any score you want, instantly.
Okay, so we know what an array is, but let's go a little deeper. Let's talk about where all these elements, all those high scores, actually live inside your computer's memory. And this is where things get a little bit mysterious. So here's a question for you. When you create an array, do you think Java just neatly lines up all those elements right next to each other in one perfect, unbroken block of memory? It seems like it would, right? It would certainly explain why it's so fast to access them.
Well, let's settle this little memory debate. On one hand, you have the simple answer you hear all the time. Yes, of course, they're stored in a perfect continuous block. But then there's the real answer, straight from the official Java specification. It's not actually guaranteed. See, unlike other languages, Java gives its virtual machine, the JVM, the freedom to manage memory however it thinks is best.
So why the uncertainty? Well, it all comes down to how Java handles its memory. Arrays in Java are objects, and they live in a place called the heap. You can think of the heap as this big shared pool of memory for your entire program. And as your program runs, this space can get a little messy. So Java has this automatic cleanup crew called the garbage collector that comes through and tidies up. And it might even move your array around to make space. Because of all this dynamic activity, the JVM just can't promise your array will stay in one perfect block forever. So here's the most important takeaway from all this. For all practical purposes, you can and you should think of your array as a single continuous block of memory. It acts that way, and that's why you get that super fast access. But as a developer, you just need to know that this is a convenient illusion. Under the hood, it's a detail the JVM handles for you, not a strict promise like you'd get in a language like C++. Okay, let's switch gears and get practical. The good news is you don't have to manage arrays all by yourself. Java gives us this fantastic toolkit called java.util.arrays. It's a special helper class that's just packed with tools to do all the heavy lifting for you. Let's look at some of its greatest hits for changing up your arrays. Need to sort those high scores from lowest to highest? Bam! Arrays.sort has got you covered. Want to reset the entire scoreboard back to zeros? Arrays.fill does it in one simple line. And if you need to make a backup copy of your scores, Arrays.copyof is your best friend. Seriously, these are huge time savers.
This helper class is also amazing for just looking at what's inside your arrays. Equals can tell you if two different high score lists are completely identical. ToString is an absolute lifesaver for quickly printing out what's in your array when you're trying to fix a bug. And if your array is already sorted, which, hey, Arrays.sort just did for you, binary search can find a specific score with lightning speed.
All right, for our last big topic, we need to talk about something, well, quirky.
Arrays have a very interesting and important quirk that every single Java developer needs to know about. It's a concept called covariance, and it hides a very sneaky trap. So, what in the world is covariance? On the surface, it's pretty straightforward. We all know that in Java, a string is a more specific type of object. Well, covariance just means that this relationship also applies to their arrays. So, an array of strings is considered a type of an array of objects. This lets you do things like assign a string array to a variable that's expecting an object array, which can seem pretty useful.
But here is the trap. This example shows the danger perfectly. Step 1, you make a string array. No problem. Step 2, you assign it to an object array variable. Because of covariance, this is totally legal. Now, that new variable thinks it can hold any kind of object, right? So in step 3, you try to put an integer, the number 12, into it. The compiler looks at this and says, sure, an integer is an object, looks good to me, but the array underneath still knows it's only supposed to hold strings. And the result? Your program compiles just fine, but the moment it runs, bam, it crashes with an array's store time.
You know, this exact danger is why a newer feature in Java, called generics, was designed to work differently. This quote on the slide explains the logic perfectly. You can't treat a list of dogs as a list of animals, because if you could, what's to stop you from adding a cat to it? Generics were designed to be smarter, to catch that kind of mistake when you're compiling your code, not when your user is running your app. It was a really important lesson that the Java creators learned from how arrays behave.
Phew, we have covered a lot of ground, from the absolute basics to memory management and even some of those tricky quirks. So let's bring it all home and consolidate everything with a final cheat sheet.
So let's quickly recap the 4 most crucial points. First, arrays are your foundation. They're fixed-sized, indexed, and hold items of the same type. Second, remember the memory mystery. They act like they're in a continuous block, but that's not a hard and fast rule. Third, java.util.arrays is your best friend, your power toolkit for doing all the hard work. And finally, watch out for that covariance quirk so you can avoid that nasty runtime crash.
And that brings us to our final thought. Arrays are the bedrock of data structures in Java. They're fast, they're efficient, they're simple. But their greatest strength, that fixed size, is also their biggest weakness. What happens when you're building that game and you realize you don't just want the top 100 scores, you want to store all of them? What do you do when you need a container that can grow and shrink whenever you need it to? Well, that's a question for another explainer.